We often talk about applying Bayesian statistics on this podcast, but how do we teach them? What's the best way to introduce them from a young age and make sure the skills students learn in the stats class are transferable? Well, lucky yes, Dogucu's research tackles precisely those topics. An assistant professor of teaching in the Department of Statistics at University of California Irvine, Mine is both an educator with an interest in statistics and an applied statistician with experience in educational research. Her work focuses on modern pedagogical approaches in the statistics curriculum, making data science education more accessible. In particular, she teaches an undergraduate Bayesian course and is the co-author of the upcoming book, Bayes Rules: An Introduction to Bayesian Modeling with R. I know, the title is just awesome. In other words, Mine is not only interested in teaching, but also in how best to teach statistics, how to engage students in remote classes, how to get to know them, how to best record and edit remote courses, etc. She writes about these topics on her blog, datapedagogy.com. She also works on accessibility and inclusion, as well as a study that investigates how popular Bayesian courses are at the undergraduate level in the US. That should be fun to talk about, right? Mine did her master's at Boğaziçi University in Istanbul, Turkey, and then her PhD in quantitative research, evaluation, and measurement at Ohio State University. This is Learning Bayesian Statistics, episode 42, recorded April 29, 2021. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach true Bayesian state of mind by visiting learnbayesstats.com. That's learnbayesstats.com. Do you want to support the podcast and unlock exclusive Bayesian swag at the same time? Then you can visit my Patreon page at patreon.com/learnbayesstats. Starting at €3, you can get various benefits like the private MBS Slack channel, early access to special episodes, selecting questions for episodes, or even coming on the show. You'll get more details at patreon.com/learnbayesstats. Thanks a lot, folks. I'm very grateful for any support you can bring me.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. What's a Bayesian? It's someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen, maybe cause my likeness lowers expectations of tight rhyming. How would I know unless I'm rhyming in front of a bunch of blind men, dropping placebo-controlled science like I'm Richard Feynman?
Hello, my dear Bayesians. I have good news. The podcast just got a new sponsor. In addition to the Patreon, this is a way to support the show, improve it, and bring you ever better content. This second sponsor is PaperPile, which is an independent reference manager software. So if you're a researcher or need to cite a lot of papers in your work or in your hobbies, I'm not judging, make sure to listen to their dedicated segment during the show to discover how they will make your life easier. So thank you, PaperPile, for supporting the show. And by the way, if you're a company and want to support this podcast, or if you know companies that'd be interested, please get in touch with me and we'll see what we can do together. And also, beyond sponsors, there is you, my dear patrons. I want to thank my brand new supporters, especially those in the food potato tier or higher. Marco Gorelli, Simon Kessel, Brady Road, and Patrick Kelly. Thank you very much for supporting the show. I really appreciate it. Now, let's dive into educational research with Mine Dogucu. Mine Dogucu, welcome to Learning Bayesian Statistics.
Thank you. I'm happy to be here. Thank you for the invitation.
Yeah, you bet. Thanks for taking the time. We have a lot of very interesting topics lined up for our recording, and I can't wait to talk about all that, especially everything you do about stats and education. But as usual, let's start with your background, because it seems like you're into the intersection of stats and education since at least your bachelor. So how come? What's your story, basically?
My story is a little bit non-unidirectional. I've actually been back and forth between places and also in terms of what I study. I'm actually from a small Mediterranean town in southern Turkey. And I completed my high school education in Turkey. Then I went to United States for my college education. And after I completed my college education, I went back to Turkey and I became a math teacher. And after that, I did my master's in Turkey. But then I came back to the US for my PhD and I've been here ever since. And the reason I tell about like where I have been is because what I study has been shaped by where I have been in my life. I always knew I wanted to teach, even from a young age. And for my love for math, actually, it's not as romantic as my love for education. I actually just liked math because I could do it and I had really good teachers. So in college, it made sense that I study math. And I wanted to become a math teacher. But I did not actually know about statistics, even though I was a math major. And I kind of figured out statistics just by pure chance. During junior year of college, I was waiting for a friend to leave her class. And I was just rolling around in the math department. And I just happened to be in front of one of the professor's door. And she had this New York Times article on her door, which basically said statistics is a really important field and studying it will be even more important in the upcoming years. So by pure chance of seeing that article, I decided to take statistics classes. After that, I basically took all the stats courses in the math department until I graduated. And then I went to becoming a math teacher. And at that time, Turkey had a new curriculum. They revised and included statistics and more statistics and probability in the K-12 curriculum. Because my colleagues who were math teachers, they came to me to ask so many stats and probability questions. I thought, okay, I need to focus on statistics education. And then I started my master's in math education, but focused on statistics education. And learning about teaching and learning was like really good. It was an eye-opener for me, but I still wanted to do more statistics. Then I went to do statistics within School of Education, like in quantitative methodology. And since finishing my PhD, I have been doing mostly statistics and data science education.
That's a very interesting background. Yeah, okay, I see how you came into that intersection. Yeah, but what's interesting is that you were really into that mindset of education and math from the beginning. So that's very nice. And actually, why did you decide to go to the US the first time for your graduate education?
I went to a special kind of high school where it was common for about like 1/3 of the graduates to go to US to study. So the reason I knew I wanted to study math or computer science, something along those lines. But the education system in Turkey is a little bit different. So when you study math or computer science, you mostly study math or computer science. But in the US, there are liberal arts colleges. They actually, like you can study math, but you can take literature classes, you can take art history classes. So they offer a diverse curriculum. So I wanted that kind of education. That's why I came to the United States.
Well, actually, already during your master, you wrote about whether math teacher use subjective probability at all. So 2 questions about that. Like, should we understand Bayesian stats by subjective probability here? And what did you learn basically from this? It seems to me that it started to shape the current work and the current topics you're researching on. Tell us more about all that.
I think everybody would agree that subjective probability is the basis of Bayesian statistics. But whether we understand from educational perspective, including subjective probability means including Bayesian statistics. So at the K-12 education level, I wouldn't say that there is Bayesian statistics education, but there are certain ideas that are given in the education curriculum that are basis of Bayesian statistics.
Can you tell us what K-12 education is? I don't know what this is. And then can you define also subjective probability, since it's not a perfect correspondence with Bayesian stats, as you say?
So K-12 stands for kindergarten through 12th grade. So anything before college and not including pre-kindergarten.
Okay. So, and that's in the US system, I suppose?
Yes, but I think we would use it also internationally, like in education, to refer to anything that comes before college usually. any kind of education.
Yeah, because in France, college is not at all university.
Yes.
So
Yes, maybe I should clarify. That is true. That is true. Actually, in Turkey too.
it's where you go after, I think it's middle school.
Yeah.
It's called. In French, it's called primary school. Then you've got college, and then you go to the lycée, which is gymnasium in German, and high school, I think, in the US. But anyways, there are many frameworks, so that's interesting to see that. Okay, so K-12, okay, and then what's subjective probability then?
So the K-12 curriculum basically has 3 definitions of probability in the curriculum: theoretical, empirical, and subjective. And theoretical, what we define, is also known as the classical definition. Basically, if the outcomes in a sample space have equal probability, then you would just take the number of outcomes divided by the number of possible outcomes in the sample space. And empirical probability definition is like more frequent. Is in the long run, if we collected empirical data, what would we see? How many outcomes would we observe? And in the subject, actually, in K-12, and also I think for Bayesians too, like that actually has a very broad definition, but usually in the curriculum it's defined as an individual person's measure of belief that an event will occur. But there, of course, we have Bayesians who argue that Bayesian is also very objective, which, like, I'm not going to get into that philosophical discussion, but in the curriculum, it is defined as an individual person's measure of belief that an event will occur. So there are these 3 definitions, and I've seen some applications of these in the K-12 from like subjective probability really being like so subjective that it's just a personal belief. I've seen subjective probability including what we would define as prior information. Like it's built on a person's prior information, what they have at that point. So it's all over the place. And the good part is sometimes there are Bayesian ideas in the curriculum that are not necessarily labeled as Bayesian, but would actually pave the path for Bayesian education in college. For instance, one of my favorite studies is this paper by What is the Probability of a Kiss by Mary Richardson and Susan Heller. They're actually having the students, like high school students, work with candy, Hershey's Kiss. I don't know if it's common knowledge for your podcast listeners, but Hershey's Kiss, the candy, like chocolate candy, that has a cone shape. So the students are trying to find the probability that the Hershey's Kiss will land on its base, basically, if thrown from a cup. So I really like this example because, first of all, usually in math classes, we usually expose students to probabilities that they can easily compute theoretically.
Yeah.
But this example, nobody knows the probability that the Hershey's Kiss will land on its base, right? So they actually have to collect data for it. But the Bayesian aspect that I really liked in the study was that they actually make students update their beliefs as they collect more data. They start with an initial belief and then they collect more data. So when you say if we should understand like Bayesian stats as we understand Bayesian stats also in K-12, the answer is probably no. Like what you think of Bayesian statistics is not what teachers teach in K-12. But at the same time, there are these very important ideas about Bayesian statistics that can be given in K-12.
Yeah, so the goal here is to introduce students to the concept of probability and how probability can change with coming new data. And I don't know if it's done right now, but that's typically the kind of thing you can also like transfer the knowledge that students learned in these classes to other classes where you think more from an epistemological point of view, where you can apply that to, for instance, something that you believe, you know, like beliefs or stuff like that, or verifying information or, you know, any critical thinking, basically. I think that's super interesting to apply that, because basically it's a skill that you learn and that you can then apply in your real life or in other classes. I don't know if you've seen anything like that or if it's something you know about.
I would not say it's contained within mathematics classes. I cannot think of any examples at the top of my head of applications of updating this information in other classes. But at the same time, this evidence building, and data is just one of the evidences that they collect, is very prevalent in scientific inquiry. And there are many like high school classes that students enroll in where they actually talk about scientific research. And I think it's very common for high school students to have like scientific fairs where some of those scientific fair presentations are based on the data that they collect. So I think I can see this being applied, but I cannot think of any specific examples right now.
I like these kind of topics and questions. Like I like these kind of epistemological education, basically topics, which I think is super important. And we can see that right now with all the COVID situation and how basically research and scientific information is digested by the general public. Okay, but then let's get back to Bayesian stats, because I'm curious why you are focusing on Bayesian stats. Because like, as I was saying, your master thesis, you were already talking about these kind of probabilities and updating beliefs and how do you do that. And so why? Because that's not the classical statistics curriculum. So yeah, first, why are you focusing on Bayesian stats? And also, do you remember when you personally was first introduced to them?
So for Bayesian stats, I had some glimpses of it at each educational step. So I was introduced to Bayes rules, of course, in my first introductory statistics course. But I think at that level, it's just I wouldn't even consider that Bayesian stats. It's just a conditional probability. And then I remember very clearly in my mathematical statistics courses, when we were actually talking about maximum likelihood estimation, I remember our professor mentioning that this is just a frequentist approach and there's more to this story. And I just remember word Bayesian being mentioned there as well, very briefly. And then when I was doing my master's thesis, because I was reading so much about subjective probability at that point, I did hear about Bayesian statistics. Obviously, I read about it. But at the same time, I haven't actually have done any hands-on Bayesian analysis myself. I was just reading it from an epistemological perspective at that point, an educational perspective. And then when I was doing my PhD, was the first time I actually took a Bayesian course and actually tried to understand the bigger picture of Bayesian statistics. I took the course in a psychology department, in fact, and I loved it so much. As soon as I graduated from my PhD, when my department asked me, what would you like to teach? And I said, I want to teach Bayesian statistics. I had an elective course to teach. And I had this professor in college who said, when you take statistics, you think you know statistics until you have to teach it. And then when you teach statistics, you think you know statistics until you have to write a book. So when you say like how I focused on Bayesian statistics, how I learned it basically, like now that I'm writing a book on Bayesian statistics, I would say that's when I actually learned Bayesian statistics. And there's still a lot to learn, of course.
Kind of the beauty of the job you have and the job many of us have is that you get to learn all the time and always. So that's kind of the beauty. Like sometimes I guess it can be a bit overwhelming and intimidating, especially I think for beginners. And actually that will be interesting to talk about that later during the episode. But yeah, otherwise, this is clearly one of the stuff I love the most is that basically have to learn each time you're doing a new model. So that's really great. And I completely relate to what you're saying about how much you learn when you write a book. I'm currently writing one too. And yeah, that's basically, this is a great learning tool because you have to organize all this knowledge in your head before putting it on the screen. So it's definitely a great experience.
I just wanted to add something to what you just said about writing a book. I think many of your listeners are like, it's more common for people to write blog posts than books. Even writing a blog post like in Bayesian statistics, like actually helps us really get our thoughts together as well.
Yeah. And for me, this very podcast helps me a lot, actually. I mean, usually I get to talk with people like you who work on topics I don't know a lot about, and I just learn so much every episode. So that's typically a great opportunity to learn and fail and then learn even more. So educate me.
Thank you for the invitation.
Actually, you're working right now on a study that investigates how popular Bayesian courses are at the undergraduate level in the US. I'm sure a lot of listeners will be curious. So, do you have any preliminary results that you can share with us on that?
Sure. I really like that we're talking about this topic because I do listen to your podcast whenever I have the opportunity. And I think this has been a popular topic among your guests. I've heard some guests say they did not want to do any teaching. They hated it so much that they just took the research route. And I think more recently, one of your guests had mentioned that they want to teach undergrad. This is their goal. And I think for listeners in general who are in higher eds, it would be good to actually have this discussion. I think it's very important because most of us are trained in Bayesian statistics at the graduate level. So trying to bring this knowledge to undergraduate level is very important. So we're very curious, like, how are actually educators doing this, like statistics educators? How are they teaching these undergraduate courses? Are they teaching them even to begin with? So these were some of the questions we were interested in. And I'm working with Jingchan, Monica Wu on this. And currently, we don't have all the results, but we have some results that we can share. So as I mentioned, in the US, we have liberal arts colleges and universities separately. And they're both like what one might understand from a university. Liberal arts colleges are just smaller. So we've looked at 50 highest ranked liberal arts colleges and 100 highest ranked universities in the US. And of all these schools, we found 6 courses out of 50 liberal arts colleges and 47 courses in 102 universities, which means that majority of schools don't offer an undergraduate Bayesian course.
Yeah, which is not that surprising, I guess.
But another interesting thing that we found, which I was not really expecting this much at the undergraduate level, which makes me really happy, is we've also tracked which majors the courses that were offered as part of. So obviously they're mostly in stats, math, data science, computer science. But we've also found it as part of actuarial science, cognitive science, economics. One school had in geological and planetary sciences, philosophy. I think philosophy makes sense. Physics, psychology, political science. So this kind of like showed us that actually it is also possible to offer a Bayesian statistics course in many different fields. I think perhaps one thing that's worth noting is all these courses have very different number of prerequisites. I think this is the biggest challenge in teaching undergraduate because all of us learn not all of us, but many of us learn Bayesian statistics after learning so much probability, so much modeling, and Bayesian stats came along. So for anyone, even when I first started teaching Bayesian stats myself, like I was trying, how can we make sure that we actually teach it with as few prerequisites as possible? And this has been a challenge. And from the schools that we have examined, it seems like all these schools have different approaches. Like we have identified a course that has only 2 prerequisites, like one calculus, one statistical introductory statistics, and then they have Bayesian. But then we also see schools where it's like it takes students to take 7 courses in statistics, math, and probability, then they can take Bayesian statistics. So it's all over the place. Like every school seems to have their own approaches. And I think with more emphasis on Bayesian education, I think hopefully we will find a way to make this more accessible to undergraduate students.
Yeah, definitely. I found that super interesting. Really like this study. And so where are you right now on this project? And what's basically your research question, if you will, or what you're looking for here? What's your interrogation?
So first, we wanted to understand how common it is and what schools require in terms of courses. We are also looking at what topics are taught. We're more in the earlier stages of that. Like if there are common things that topics that undergraduates Bayesian courses should cover. Of course, we also have our own recommendations from our own teachings, but we wanted to understand similarities and differences across different institutions, and also provide this as a guideline to other schools who might be adopting Bayesian courses in the future, because when people start teaching their own course, it's always good for them to have some template from other institutions, what the other instructors are teaching. So that's basically our goal. And we are done with data collection. We are currently writing the paper. So maybe, I don't know when you will release this episode, but by the time this episode is released, perhaps a preprint might be out.
Yeah, that would be cool. When do you expect this preprint to go out?
Our internal deadline is July 1st, but you know how things go, especially during the pandemic.
Yeah, I guess. We'll keep an eye out for that. And if the preprint is out when this episode comes out, I'll definitely include that in the show notes. I'm sure a lot of listeners will be very curious about that.
Let me show you how to be a good Bayesian.
Hey folks, as I told you at the beginning, this episode is brought to you by PaperPie, the reference manager you actually want to use. You can cite in BibTeX and search inside databases right from Microsoft Word or Google Docs. There is no way to cite faster. You can read, annotate, and even collaborate with your co-authors in the modern web app or in the iOS and Android apps, which automatically sync your library to all your devices. As a listener of this podcast, you get all these features for only $29 a year. That's a 20% discount with the special promo code GoodBayesian21. So go ahead and check out paperpie.com before December 31st, 2021.
Let me show you how to be a good Bayesian.
I'd like to ask you about the concepts that you learned about and research all year long, just these concepts to teach Bayesian statistics. So I'm curious, because you are also an educator, you have this Stats 115 course that you teach, and you have these Bayes rules book. I love the title, by the way. Well done on that. So, I'm curious, what can you tell us about the structure of both your stats course and your stats book? And how do you apply and refine the concepts, the educational concepts that you know about?
Sure. So I should note perhaps first about my course is it's mostly taken by data science majors in our institution. And even though the course has just this prerequisite, a year long of course in probability and stats. So students already coming knowing likelihood, they have seen regression, all these models. But because they're data science majors and they take it in their last year, they actually come also with strong training in computing. Mm-hmm. And related to the book is a collaboration between Alicia Johnson, Miles Ott, and me. And Alicia teaches at Macalester. Her students also have a similar background. Miles is at Smith College, and he actually taught his course without a probability prerequisite. So we know that the students that we're writing for in the book have different backgrounds than our students, but at the same time, this book has definitely some probability and computing strength in it. So even though we don't expect book readers all to have this earlier training, we do provide enough information throughout the book to get them up to speed in such a course. To give an overview of the book and the course, which are very aligned, the book is divided into 4. We first start with some Bayesian foundations, then we move on to posterior simulation and analysis. Then the last 2 units are completely modeling based. So the 3rd unit is regression models. Mm-hmm. And the last unit is hierarchical models. I teach in a quarter-based system in the US, so our academic terms goes 10 weeks. So I cover everything up to hierarchical models. I cannot cover that. But Alicia teaches in a semester-based system, so she can go all the way up to hierarchical models. So I'm telling all this information in case any listeners are interested in teaching or learning, to give an overview of how long the book is and how it can be aligned with learning. So some of the concepts, like the first basic concepts in the course and the book, by the end of first unit, what we expect students to know is we start with Bayes rules, we go into beta binomial model, and we basically use the beta binomial model to actually explain the basic concepts. After they understand, they cover beta binomial, then we move on to other conjugate families like gamma Poisson, normal, and so on. By the end of first unit, they should understand basically that what happens to posterior when sample size increases, for instance. What happens to posterior when the prior is highly informative, and so on. So these things they cover in the first unit. In the second unit, we move on to posterior simulation. So that's where they start learning about Markov chains, basically. And they actually also write code for Metropolis Hastings algorithm to understand the reasoning behind Markov chains, because we specifically use Metropolis Hastings because it's the easiest to code and understand and teach in a short span of time. And then we move on to posterior inference. But now that they have their approximations for the posterior, what can they do with it? Credible intervals, Bayes factor, hypothesis testing, and also predict. The regression models, the third unit, the last unit for my course, is basically normal regression, Poisson and negative binomial regression, logistic, naive-based classification, and same with hierarchical, it's basically modeling. This is basically the overview of the course and the book.
Is there a particular field you think these kind of resources can be particularly helpful for, or do you think it can be applied and studied by most students in most fields? Or I don't know, to put it concretely, do you have more students in the social sciences in mind for these kind of resources, or maybe students more in the hard sciences, let's say?
So I wrote the book thinking, of course, the starting point of the book was our own courses. And we teach in statistics and data science programs. So definitely our primary audience is students in mathematical sciences, statistics, data sciences. But that does not mean students in psychology or economics cannot necessarily use this book. In fact, in my courses, I have students from psychology department, students who are majoring in quantitative economics. They also take these courses. So they definitely do well in these courses. So I can see the book being read by students from other majors as well. And also, even though we are obviously writing this for an undergraduate audience, it does not necessarily mean only undergraduate people can use this, because many people are not necessarily trained in Bayesian statistics in undergraduate. So anybody actually who knows a little bit of statistics, a little bit of probability, can read the book and use the book. And I can also see some people specifically using certain chapters, perhaps somebody who's a practitioner, not necessarily in education, using this book for teaching or learning, they can actually perhaps go towards more the regression models chapters, specifically looking for understanding posterior predictions and so on. Or if they're just interested in understanding Markov chains, they might just go to the Markov chains chapters, possibly.
That sounds super interesting. And let me ask you about general best practices to teach Bayesian stats. What's your idea there? And what are the big principles that you guys are trying to apply and work on by writing this book and by teaching these courses?
So I think a couple of things that are borrowed from not just teaching this course, but just teaching in general and also teaching probability. One of them is checking intuition. Throughout the book and the course, we do these by simple test yourself quizzes. What do you think is going to happen if the prior is like this? Or what's going to happen if the sample size increases? Trying to see if students already have these information is very crucial in general in teaching probability, because we all already have some ideas about probability. Either they're correct or incorrect. It doesn't matter, but we already bring this pre-information with us to the classroom as learners, right? So checking those intuitions is very important in teaching, because it tells a lot about what students are thinking, where they are, what they know. This, I think, is an important part of teaching Bayesian statistics. Another part is active learning. And this is not just for teaching Bayesian statistics, but just in general. Like, lecturing goes only up to a certain point. Students have to practice things themselves because the learner constructs the knowledge themselves. So they have to take active role in their learning. So like, rather than saying like, this is what happens when you change the prior, this is what happens when you change the likelihood, they actually have to do that by themselves and see what happens when the likelihood changes, see what happens when the prior changes, and so on. So giving enough time for students to practice these concepts is extremely important. And also, I usually actually use my Bayesian statistics courses to go over some frequentist concepts to see the relationship between the two courses. Like when we do hypothesis testing, students have been doing hypothesis testing for like 4 years when they come into my course, but they've never actually questioned the hypothesis testing they have been doing. So like, I think drawing links between Bayesian course and the previous course is extremely important for students to understand what they have been doing all this time and how Bayesian methods are different to what they've been doing so far.
Yeah, that's always interesting. Do you really try and compare the two methods, or do you really start from scratch as if you were reteaching them the whole of statistics and probability?
Oh, no, I definitely not do everything, like every single comparison between frequentist and Bayesian, but at the point, like for instance, when we are doing hypothesis testing and we talk about Bayes factor, I ask them like, what have you been doing previously?
Yeah.
And until that moment, they don't realize that they did not question what they've been doing. And that's like usually an aha moment for them. Also, another point is like when we do, like at the very early stages of the course, when we talk about prior and likelihood, like they've always used MLE, right? Maximum likelihood estimation, but they don't realize that, like they haven't questioned that was just that part of the analysis. Now there's prior that they link, like they understand frequentist, like MLE even better after they actually use prior and likelihood.
Did you have any other principles that you wanted to talk about and that you're applying in this work, or is this the summary you wanted to make?
No, I think there are a few other approaches that we do. Like, for instance, the book we have and the courses we teach are more computing heavy rather than math heavy.
Yeah.
But we always also cover the math. But I think our approach can be summarized as computing first, math later. Like, students should first be able to compute things, rely on writing functions or already built-in functions. And once they can use these methods, then we can move on to why do the things work the way they do, and we will prove them to you. But mathematical derivations first actually put off students. They are challenging at first, but if they know how things work, they are more interested in knowing why does it work. And in fact, in the book, we present some of these as like more optional, more towards the end of the chapter. And sometimes during class, I don't finish a topic, like I didn't get to the math derivation. They're already asking me, why is this happening? Can you prove it to us? And then next class, I can actually go over the proof. So I think computing helps raise that curiosity in learners that they need the math and then they can get to the math. And also in terms of computing, we first do the computing from scratch ourselves, then actually use some built-in packages or functions that are already existing.
I love that. I really love this principle of computing first and then going into the math. This is typically something I would welcome very much during my studies. I got introduced to stats mainly through mathematical derivation, and I was doing stats with pen and paper. And to me, that was, well, intellectually interesting, the course, but then doing the exercises and so on was, pretty boring because you couldn't really understand why you were studying that, basically, because with a pen and a paper, the problems you can study are pretty trivial. So you don't really understand how all this power of statistics analysis helps you to do in real life and in research and in data science in general. And so I always thought that, gosh, if I had the opportunity to fire up some Python or R or any other language, and just code up something that would give me samples from a probability distribution, and I would have been able to visualize that and see how that changes with the different parameters and so on, and how the different probability distributions relate to each other. So for instance, conjugate priors and so on. That would have made it much, much more, practical. And I would just have loved statistics and probabilities from the get-go instead of waiting for several years and finally getting in front of a computer and firing a Jupyter notebook and seeing this magic in front of me happening. So I really love where you're going with that. At least for me, that would have been awesome, because I agree that mathematical derivations are awesome, but starting with that can be very first intimidating and just very dry if you're not really in that because you want to do math.
Actually, speaking of starting point, our book starts with a quote from Beyonce. We don't even start with any math at all.
But I don't know, maybe Beyonce is very good at math. I don't know about that.
She has a quote that says, "How can we live if we don't change?" It's from one of her lyrics.
Well, that's super nice. We definitely will put that book in the show notes for both fans of Bayesian stats and fans of Beyonce. And actually, just maybe quickly, but I wonder how you handle the choice of software, actually, which can be overwhelming for beginners. Like, I often see people in the paradox of choice. Like, they are all like, oh, what should I choose? PyMC or TensorFlow probability or Stan or, I don't know, Turing or any other PPL, and they end up not choosing anything because they are kind of paralyzed of not making the right choice. So I wonder how this is going for you in your classes and how you handle that.
So I learned Bayesian stats using Stan. And so when I first started teaching, I also used Stan. And when we were writing the book, we did have a discussion on what we want to do, whether we want to go with JAX or Stan. And I think the earlier versions of my course was taught with bugs. So it was definitely a discussion, and we went with Stan. And the book proposal reviewers also suggested we go with Stan. But because we are teaching in stats department and we usually teach with R, we actually use the R Stan package. And when we teach actually with both with R Stan and R Stan ARM. So R Stan actually teaching the basic idea behind R Stan gives us the option of students being able to fit more complex models if they wanted to. But at the same time, R Stan ARM saves a lot of time during class time, especially with posterior analysis, because it's like with using packages like base plot, like we can really do really nice plots really fast and actually get a good understanding of posterior really quickly in a class time, and without delving into like dealing with arrays in R, given the R Stan output. So we teach both R Stan ARM and rely a lot on base plot. But we've also developed our own package to help for whatever was missing for us. So we have this package called Bayes Rules. It's currently not on CRAN, but it's on my GitHub actually. And the package has two purposes. One is part of it, we've talked a lot about building students' intuition about what happens to posterior when prior and likelihood change. So part of it is actually gives plotting functions for beta binomial, Gaussian Poisson, normal. So students can enter parameters and data, and they can see how the change is happening. So we use that in earlier chapters. And we also have a couple of functions for modeling, which basically helps with the posterior analysis. In regression models, we have a couple of cross-validation functions for different models. And we also have, like for logistics, we have confusion matrix function to analyze posteriors quickly. And like I said, students actually do this once by themselves. They actually do their own posterior predictions once for a given X value. What would be the posterior prediction? And then once they learn that, we don't actually spend time doing posterior predictions one by one. They rely on these already built-in functions.
Yeah, definitely doing posterior predictive checks and even prior predictive checks, just doing forward sampling in general, I find just so powerful to understand your models and the logic behind them and so on. I mean, this is something I use all the time in my models, and I couldn't live without them, or not live, but statistically live without them. So, I'll put also the link to your base rules package in the show notes of the episodes because I think people will be interested in that. Let's zoom out a bit. And I'm curious, in these courses, in your classes and then in your book, first, I'm curious, what are the essential skills you're trying to instill in your students? And also, what are the most common mistakes or difficulties that you see?
So actually, in my courses, it's not just statistical concepts that I try to install. And I think this perhaps important to mention to listeners too, because I believe there are also listeners who might just be in their beginning journey of Bayesian statistics. I think one thing I try to install in help students understand is understanding about their own learning, like how we learn. So students get really stressed when they don't understand something the first time. And I actually these are senior students, right? So even understanding p-values for any one of us, how long that took, like none of us understood it the way we understand today, just taking by one statistics class. It's a process that evolves. And same with Bayesian statistics. They take one lecture, for instance, they don't understand a certain thing, but they do by the end of the quarter. It evolves over time. So I think understanding takes time and it has different levels also. So they definitely see with verbal prompts in class. And my goal definitely in teaching my students is always doing the full cycle of analysis. So yes, we do pieces of analysis in different parts of the lectures, but they should be able to look at their problems from a full cycle, from starting from setting their priors to all the way to posterior analysis. And so I do teach with very hands-on approaches, they should be able to drive their own questions, get the data, and actually analyze. So we do have a big project component in the class where students have to do their own projects. And I think that's a very important part of their learning. Students also agree to this, that they can do a full cycle of data analysis. And in terms of mistakes, definitely, I don't know if it's mistake or discomfort, but it happens a lot in earlier stages of the course. Students are reluctant to set their own priors. So we have homework assignments, quizzes where I say, whatever your prior is, it's your prior. You can set it. And everyone in this class can have different priors. That's okay too. And they are absolutely uncomfortable at this at the beginning, which is understandable because all the statistics courses we take prior to Bayesian statistics actually say we get taught as if there's only one single answer, there's only one correct way of doing things. And even from frequentist sense, even if you look at frequentist statisticians, they don't necessarily actually arrive at the same answer using the same tools. They do actually have their differences. But in education, that changes. Everybody has the same answer. So when they get to Bayesian, that's actually extremely difficult for students to get out of that mindset and to have their own prior ideas.
Yeah, definitely noticed that too. Now that I'm working full-time at the PyMC Labs consultancy, where we're doing some corporate teaching. And so, yeah, I definitely got the same experience with priors. And although we really insist on the fact that there is not one good prior. And also the nice thing is that put your priors and you'll see what happens. The nice thing is that MCMC will tell you if something is really going wrong. So that's the nice thing. It will cry and tell you that your model has a problem first. And something I also noticed is sometimes students have difficulties setting likelihood function. I never had these fears, so it was pretty surprising to me. But basically, they seemed lost with the choice of likelihood function that you can have. It was like, but I don't know, which one should I choose? And again, it's kind of the same reasoning, there is one good likelihood function, so which one should I choose? So the answer is the same as for prior. Well, try one. If it doesn't work, you will know it. You will notice. I don't know if you saw that already, but I was pretty surprised by that the idea was I don't know which likelihood to choose. How do I do that? But basically the reasoning behind that is always the same. It's what's the right answer? What is the right likelihood? Which is, I think, the core of then what you have to make students understand.
Absolutely. Part of it is like that the education system we all go through is always there's only one correct answer.
Yeah,
And we
exactly.
have to find that golden answer. And if you find it, we win. But on the opposite, statisticians are always dealing with uncertainty and all have different answers often.
It's a good thing of Bayesian inference because it puts so much emphasis on uncertainty and the existence of uncertainty and the importance of estimating it, that with time, students get them. But it's true that at the beginning, it's a bit of a mind shift you have to do. I'd like to zoom out even more now because, as I think some listeners know, we've been in global pandemic for more than a year now. So if some listeners out there don't know about that, yeah, we've been in the whole of Earth has been in a lockdown because of a global pandemic. So of course, teaching went remote. I'm curious if that changed anything for you, and I'm guessing it did, Mine, but like, how did it challenge the teaching experience? How did it change engagements with the students? How did you get to know them in that way, and which lessons you drove from this experience more generally?
So it definitely has changed a lot, definitely. And for me, because of our academic calendar is very different than most schools, we started our spring quarter in March. So we actually, at the beginning when shutdowns were happening, we immediately went into a new academic term, completely remote. So some people actually, in the middle of their quarter or semester, they've changed. So that might have been slightly easier because at that time I would have known my students. We would have actually built some understanding of topics, but we immediately started with remote. And for anybody, students or professors, we did not know what was going on. For most of us, some of us have taught online, but it was not very common. So it happened all of a sudden. And I think there have been many challenges with it, both for students and professors. I think at this point, we're all very tired and cannot wait to be back on campuses. I think from student camp perspectives, like they all had to go home and they all have very different living situations. Like some of them have internet connection issues. I do too, very often. So that has been definitely a challenge. Some of them went back to their own country. So time zone differences became a very big issue. Like right now, still I teach so many students from China and we're on very different parts of the world. So I have to actually make sure I put some meeting times at 5 p.m., 6 p.m. of my time so that I can actually meet my students. Otherwise, I would never get to see them at all. So this definitely has been challenging, but I think there have been some good parts that I think have been good, or at least I'm trying to look at this from a positive perspective. Like one thing that students have really hard time understanding that is that professors are humans too. Like we just live our life too. Like sometimes in real life classes, like in-person classes, they would see me on campus either eating food or see me on the bus, like school bus, because there's a shuttle that goes around our campus, and they would get so surprised. Like a professor cannot eat or can be on the bus. But now that I'm teaching from my home, they actually, I think, see that human aspects of our lives like more. Like they don't just see us as a professor because they see me with my cat jumps on my desk during office hours. So they know like I have a home life, I have a family. So those parts have been, I think, good, that making that kind of connection. And I think from a pedagogical perspective, good part of it has been the videos, especially for teaching computing, the screencasts have been extremely helpful. And I think that's definitely something I would move forward in my teaching, because I can see whenever I'm screencasting for students who are learning R, for instance, for the first time, they need a lot of practice. They don't necessarily remember how I did certain things. So they actually go back and watch these videos over again, certain parts of the videos. So I think the small screencast videos I will keep in my future teaching as well.
Yeah, that's super interesting. And yeah, definitely, I think like the business world had the obligation to go remote too. And I think things won't go back to the status quo ante, if you will. Like, I think the remote practices will stay not as much as they are right now, because as you say, I'm guessing many people want more social contact now, but I think there won't be a complete regression to the status quo ante, and that some good practices that emerge and better practices that emerge with the forced remote will stay, like, for instance, some conferences that don't have, or some meetings that don't have to be, on location. That will be something, I think, that comes out, and that's very positive out of this forced situation, is that it forced a lot of big, slow to move institutions, like often education is, or big companies, to kind of go ahead and modernize a lot their practices, which is, I think, a very nice thing for most of the people working in there. And so, yeah, and well done adapting yourself to all that. I mean, this must have been super challenging. You must have done that, I think, in a record time. So, I mean, well done on doing all that. Actually, you talked about the fact that you have students coming from all over the world. You yourself have a very interesting background, and I know that you work on accessibility and inclusion through your book. So can you tell us how exactly?
So even in the early days, Alicia, Miles, and I had decided that this would be one of our primary goals in writing this book. And the first thing we had decided was we can definitely talk about access if we can do our book open access. So it is open access. We've released 8 chapters of the book, and we hopefully will release the rest of it soon. And neither of us, like among the 3 of us, we did not know much about accessibility and inclusion, and we're still learning on the topic. So we actually started reading about it, see what we can do. So one of the things we've done is we've learned about how to make visuals so that it's accessible to colorblind people. So we worked on that. And also through writing this book, I've started using a screen reader. Mm-hmm. Basically, it's used for visually impaired people to listen to what text is written. And we wanted our book to be able to read by screen readers. Through this, while I was reading our book through screen reader, I realized that we need alternate text for images because the plots are not obviously read through screen readers. What I realized is actually our Markdown, which we use for writing the book, does not actually support alternate text. I actually was very surprised to find that I would be the first one to actually ask the R Markdown team, because R Markdown is like, I wouldn't be surprised if the number of users are more than like 100,000 of users. So we requested the R Markdown team, can you please actually give us this feature? And they actually did it, which was very nice. So I think we now have used alternate text in all our plots that are released. So the images should also be screen readable for readers. And we're trying to improve those as well, like as we go along, because we're learning how to writing alternate text for plots are extremely difficult. So we're learning how to make them even better. And in terms of inclusion, throughout the book, we try to make sure we use like names that are not just from Western countries, but from all over the world, because our students are from all over the world, our readers are from all over the world. So we wanted them to be represented in the book. And in terms of citations, we also try to pay attention. That's probably the hardest part of it. We don't always want to cite the same people from the same countries, from same demographic groups. So we want to broaden that. We actually got that idea from the Data Feminism book. They have certain criteria on their book that they used while they were writing their book. So we based it on that. And also with data sets, like we try to pick data sets that are from diverse fields of studies, so that our readers would be engaged in the material, no matter what their background is.
Yeah, this is amazing. Well done on doing all that. That's really impressive. I think a lot of people will appreciate that. And actually another initiative that you're spearheading with Alicia Johnson and Miles O, which I love, is the Undergraduate Bayesian Education Network. So can you tell us what it is, how it works, and maybe what's the goal?
So we've talked briefly about like how there are few number of Bayesian courses at the undergraduate level, but whenever we talk about Bayesian courses, there are always people who are interested in teaching these courses. So we thought that there should be some space that brings together people who already teach such courses and people who actually want to teach such courses, who are at the early stages of perhaps planning their courses. Stats education, we have similar subgroups of people with similar interests. Basically, idea behind such groups is like you can ask each other any question you want, from like picking a textbook to picking software or debugging your code, or you've seen some article related to Bayesian statistics somewhere. So it's like a virtual space where you can share any resources that might be helpful for teaching Bayesian statistics. It's a virtual space on Slack. Basically, it's a Slack workspace that we use for conversation. Also, we have a website where we compile resources for instructors. It's in the same like network website. So we share some textbooks we know that people use in their courses, some papers related to teaching Bayesian at undergraduate level, also some other resources, like including your podcast, are provided there. So,
well, thanks a lot for that.
yeah, so anything that we think might be helpful for undergraduate instructors are compiled there, basically.
Yeah, that's amazing. And I will definitely put the link to that workspace in the show notes because this sounds super useful, actually, and very helpful. I really love this idea. Coming from the open source community side, I mean, I, of course, love these kind of initiatives. So we're getting short on time. So I'm going to ask you one final quick question that I like to ask before asking you, of course, the two final questions. But yeah, a question I like to often ask to my guests is if there is a particular method or type of models that you particularly like and would like to share with us.
I guess I can go with hierarchical linear models for two reasons. One is like when I was actually a student and learning hierarchical linear models, it really helps me understand like variance in general and covariance like really well. Basically getting at the conclusion of basically everything is a linear model and making all the connections between like even like I remember at the same time taking my HLM class, I was also taking an item response theory class. Like even connecting IRT with HLM was a key point in my head. So from learning perspective, it was very important. And from practice perspective, I like HLMs also because I work with educational data and students are usually clustered within the classrooms, which are clustered within schools. So from practical perspective, they are very useful for my kind of research.
Yeah, awesome choice. I love hierarchical linear models too, and I use them all the time. The hard thing is that they can be very tricky, especially for choice of prior. Like, so you definitely have to do forward sampling on these models and just try to understand them and their structure better. But the good thing is that they are difficult to understand. So that means that they are very polyvalent and you can use them for a lot of models because precisely they are very versatile. But it's because of that they can be tricky to use. But yeah, definitely love that. Okay, Mine, before letting you go, I'm going to ask you the last questions I ask every guest at the end of the show. So first one, you told me you listened to the podcast and thank you a lot for that. So I guess you know what the first one is. If you had unlimited time and resources, which problem would you try to solve?
I think I would focus on homelessness. There are two reasons for it. Yeah. One is I live in California, which absolutely does not have affordable housing and has a very big homelessness problem. The reason I also picked this problem is like it really affects people's everyday lives, but also like there are enough resources. Like we do have enough resources. Like the reason this problem is not solved is because of policy making. So that's why I think it's a very important problem to solve.
Yeah. Very, very interesting answer. And I can understand why being in California would give you this idea. And second question, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
To be honest, at this point, I would like to have dinner with any scientist, given the pandemic.
Yes,
like with any of my
that's a very good answer. I can completely understand that.
Joke aside, I would have really loved to meet Webb Du Bois, who is a sociologist by training, and I would love to talk to him about his data visualizations during like the 1900 parsed exposition. It's just there's the human element, there's the data visualization element. There's so much like I would have loved to talk to him over dinner.
Yeah, super choice. And you're the first one to answer that. So first
really?
sample, that's great. I love first samples. Well, thanks a lot, Mine, for this fascinating dive in the world of stats education. As expected, I learned a lot about how best to teach Bayesian stats, how we can foster accessibility and inclusion, and I try to heed your advice in my own teaching. And as usual, I put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Mine, for taking the time and being on this show.
And I learn a lot from your podcasts as well.
Well, thanks a lot. That's one of the best feedback I could have. That's exactly why I created the podcast. So thanks a lot. And take care, and hopefully see you soon in person in California or elsewhere.
Hopefully.
Bye.
Bye.
This episode was brought to you by PepperPie. PepperPie is the reference manager you actually want to use. It integrates seamlessly with Google Docs and Microsoft Word and allows for live collaboration. Learn more at paperpie.com and enter the promo code GoodBayesian21 at checkout for a 20% discount. This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher or on Podchaser, and visit learnbayesstats.com for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman with MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thanks so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.